Is here. Welcome to the lecture about pulleys. Pulleys are considered types of simple machine. They make our job easier. For instance, in this case, if you want to bring the 100 Newton up, you can actually apply the force down to bring it. You just use a piece of cable. You can stay on the ground, and then by pulling the object, and by pulling the cable, you can actually bring the object up. Pulleys are frequently used in any system of constructions and other systems. Is a type of a machine that make our job easier. And then again, by changing the direction of force, look like number 1, A, or it may actually make our job easier like B, that I'm going to talk about how much they make our job easier. In this case, the mechanical advantage, what is our effort? The effort is here, and the load is down here. The same description for pulleys, we can say mechanical advantage is equal to load over effort. Remember, 100 Newton is equal to 10 kilogram, kind of very similar to that. Now in A, you are going, again, if you have one cable, the force all over that cable is the same, because cable cannot be stretched. We assume cable is rigid. The other one, we assume that there is no friction on the pulleys. So when there is no friction and the cable is rigid, everywhere on the cable you have the same force. In this case, the force of effort, that I don't know how much that force is, this force is going to be everywhere. So I'm going to call this force, you can call it effort or other force. You can just simply call it a tension that we showed with T. Now in this case, you can see if you look at the pulley up there, in the pulley you have a force of 100 Newton that's going this way, and then you have a force of T that's going in this way. I'm talking about pulley number A. So in A, T is equal to 100. Your mechanical advantage is simply 100 over 100 is 1. It's not advantage. Now for B, on the B, the force here, the tension on the cable, that we don't know. But how can we calculate the tension? So just look at one pulley. If you look at just this pulley down here, okay, draw the free body diagram for the pulley of B. So if I draw the free body diagram for pulley of B, I'm going to have something like this. I have 100 Newton that's going down here. I have one tension here, one tension here. Again, I cut it from here. You see that? There are two pieces of cable that they're going up. Each of them, there is a T. In this case, you can say, again, if you do summation of force on the Y, remember, these are all statics. In static, the summation of force should be 0. So now the summation of force should be 0. Then you can say 2T, right, minus 100 is equal to 0. Summation force on the Y is 0. That's the definition of statics. So T will be equal to 50 Newton. Mechanical advantage is equal to load, which is 100, divided by your effort, which is 50. So your mechanical advantage is 2. So you, by applying a force of 50 Newton, you can actually lift an object with 100 Newton. Now, what we are losing, we know there is no free lunch, right? You are losing your time. In number B, you have to collect a lot of cable just to bring that guy a little bit up, right? You have to go 2 times. That's where you're timed on doing that. So I have a crazy shape here, that I have a system of pulleys that they go forever. So now I want to find mechanical advantage for each of these guys. As we discussed for the first one, the mechanical advantage is 1, and then we actually did the calculation. For this one, we call this one A. This is A. This is B. This is C. And This is D, and this one E. On the first system, the amount of load and effort are the same. So in this case, T is equal to 100. In the second one, T was 50. On the third one, in C, let's just look at the pulley C. If you look at pulley C, you have one cable here. Always cables are in tension, so you put them upward. We have 3 cables going up, right? If you cut it from here, and then you isolate this system, you can see there are 3 that going up and then 100. So we have T, 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 and 100 Newton down here, which is your force. If you do summation of Y equal to 0, then from here you have 3T going up minus 100 is equal to 0. T is equal to 100 divided by 3, which is 33.33. That's for C. Mechanical advantage for C is equal to your effort, your load over effort. Your load is 100, the effort is 33.3. We already know that. The mechanical advantage for C is 3. For 4 is you have to you cannot disconnect it from here, because you see these two are connected together. I'm going to disconnect it from here. If I disconnect it from here, count the cable, right? 1, 2, 3, 4 cable. So for D, I'm going to draw it look like this. So in this system, you have 100 Newton here, 1T here, 1T here. They're actually touching this guy. And then 1T here and 1T here. So 4T minus, we are doing D, 4T minus 100 equal to 0. From here, T is equal to 100 divided by 4, which is 25. Then your mechanical advantage is equal to 100 divided by 25 is 4. For E, you can actually prove that the mechanical advantage for that is 6, and then the amount of force is 100 divided by 6, which is around like 15, 17, something like this. Okay, thank you very much for listening to the lecture about pulleys, and it was great having you watching this video.